For our next unit, we're going to start looking into statistics and analyzing different kinds of data. So to start with, what do we need to be able to do with this data? Well, for one, we're going to need to be able to calculate. We're going to calculate things like the mean, median, mode, quartiles, and standard deviation, and even a couple more things that aren't listed here. We need to be able to interpret. We're going to explain the meaning of whatever stat we're looking at. For example, the median home price in Wilmington is currently $168,500. You want to know, what does that mean? And we're going to analyze, examine the stats closely, compare and contrast with other data. For example, college football playoffs. How did the committee use the data to rank the top 6 teams? So we're going to find all this data and not just find it, but use it to analyze and predict and, see why we do things the way we do. So to start with, we're going to review a little bit. We've got measures of central tendency. And the way we do our central tendency, we have mean, median, and mode. So the mean is the average. Okay, so we add up all of our data and we divide it by the number of items that we have. Okay, then we have our median, which is the middle number, but you have to make sure you line up your data in order from least to greatest so that you can find the middle in order. And the mode is a number or numbers that occurs most often. There's one mean and one median, but there can be multiple modes. Sometimes there's no mode. It just depends on if some of the data repeats. Sometimes it's better to use one particular measure over the others. Usually we'll use the mean whenever we're measuring the central tendency, right? So if there's no outliers, nothing crazy going on with your data, we'll look at the average. But sometimes if there are outliers and there's no big gaps along the way, we'll use the median. We'll kind of find the middle of the data. Okay, and remember, your outliers are the ones that kind of stand on the outside of your data, so something that's super far out and doesn't kind of fit with the rest of it. Sometimes then the median will be the best option to kind of get the middle. And then if you have a ton of numbers that are repeating, then we might use the mode. The mode's generally the one that you won't use as often. The mean's the one you will use the most often, but sometimes if you have outliers or what we call skewed data, we'll switch to the median. Okay, so for example, we want to find the class average, or finding your class average. On his first 5 history tests, Brian received the following scores: 82, 96, 92, 83, and 91. We want to know what he must earn on the 6th test to have an average of a 90. Alright, so we're going to call this 6th test X, right, because that's the one we're looking for. And we want an average of 90, so if I add up all 6 of his scores and divide it by 6, I should get 90. So we could say 82 plus 96 plus 92 plus 83 plus 91 plus that 6th test X, and divide all of those by 6, and we should get a 90. So to simplify some, I add up all the 5 test scores from before, we get 444. So now we have 444 plus x over 6 equals 90, and we just have an equation to solve. So the first thing I need to do is get rid of this denominator 6. I'm going to multiply to move it to the other side. So we get 444 equals, and then 90 times 6 is 540. Forgot the x in there. 444 plus x equals 540, and then we're just going to subtract. So we're going to subtract 444 from both sides and get that x equals 96. So he needs to make a 96 in order to have an average of 90 for his test. Quartiles are values that separate your data into 4 subsets. Alright, so just like your median cuts it in half, like you find the middle of your data, the quartiles do that and cut it into fourths. So the median is actually our second quartile. Right? That's the easiest one to find. That's the one you'll find first. Then you take your lower half, whatever the lower half is, and find the middle. That's your first quartile or your lower quartile. And then you take the top half and find the middle, and that is your upper quartile. Alright, so we've got the middle is your median, the lower, and then the upper. Now, whenever you find the median, if you use that as your Q2, your second quartile, we're not going to use it again in finding the upper and the lower. Alright, and we'll talk more about that with some other examples. So for this one, we want to find the median, lower, and upper quartile of this data. So the first thing I need to do is put it in numerical order. And we got this 22 over here. It's kind of out by itself, but that's part of our data too. So if I look across, it looks like the smallest one is a 14. So I'm going to put the 14 first, and then I'm going to go ahead and cross it out just so I don't use it again. And then I'm going to look for the next highest number, which I see is 16. Okay, then I see two 17s. Alright, then it looks like the next one might be a 20. And then that 22. It looks like, oh, forgot my 21. There's a 21 in there. Then 22. Then we've got a 26, 28, 29, and a 35. Alright, so the first I'm going to find is the median. Find the second quartile. So to do that, I'm just going to kind of cross out the ends. And I'm not actually going to cross them out just so I can still use the same data. So I'm just going to put a little bar on the bottom. So we got both of those. And then we come in one from each side. Keep going until we get to the middle. So now this 21 is my second quartile, or my median. Alright, so I'm going to call that Q2. And it's 21. Alright, to find the upper and the lower, switch colors here. We'll go with orange. Let's switch to an orange. Alright, so to find Q1, I'm going to take just the numbers that are left, so not including the median, and I'm going to find the median on this side. So to do that, I'm going to do the same thing, start crossing off from the end, and I get down to a 17, so that's my Q1. And then the same thing on this side, take the upper half and start crossing off, and we're going to get to the 28 that's in the middle. So my lower quartile is 17, my upper is 28, and my middle quartile, or my median, is 21. We use this information in a box and whisker plot. Okay, so a box and whisker plot organizes and displays data by dividing a set of data into 4 parts using the median and quartiles. The box, part of the box and whisker plot, represents the interquartile range, and that is the difference between the upper and lower quartiles. Right? Data that are more than 1.5 times the value of the interquartile range beyond the quartiles are called the outliers. Right? So that means if I find my interquartile range, and that's the box part, right? And then I take my interquartile range times 1.5 times, and then I take that value up and below the highest and lowest points of my interquartile range. Anything past this point on either side is what we would consider outliers. So anything over here and anything over here. If they fall within that range, then they're not outliers, and we don't have any outliers for that data set. You can have a bunch of outliers, right? Not likely that you really have a bunch, but you can have multiple. You can have one, and you can have none, right? Not every set of data has outliers. So for this one, I want to find the mean, median, lower quartile, upper quartile, and any outliers for this data set. So the first thing I'm going to do is go ahead and put them in order, because I'm going to need them in order for the median and the 2 other quartiles. So we've got the lowest looks to be an 8. Put my 8 down here. And then it looks like we jump to 13. And I see a 14. A couple 16s. An 18. 2 18s. Looks like 2 20s. A 22 and a 30. Alright, so first we're going to find the median. Right? I think that's usually the easiest one to find. So I'm just going to start marking them off the ends until I get down to the middle. Alright, so here's my middle number. Now remember, if I have 2 numbers that are in the middle, like if I have an even number of data points, you have to take the average of those 2 middle numbers. And once we've done so far, work out nicely with one middle number. Alright, so my median, put down here, is 18. Alright, we got to find Q1, Q2, 3, and our mean. Alright, so I'm going to keep going with the quartiles. Okay, so we've got this side over here. We'll cross off, cross off. There's my Q1. And then over here, cross off, cross off, cross off. There's my Q3. So we got a 20. Okay, to find the mean, we've got to add everything up and divide it. So we're going to say 8 plus 13 plus 14 plus 16 plus 16 plus 18 plus 18 plus 20. Goodness, plus 20 plus 22 plus 30. And divide it by how many we have. So if we count all these up, it looks like we have 11. And when we add up the entire numerator, we get 195. And then we divide that by 11, we get 17.7272, and so on. So if I round that to the tenths, our mean is 17.7, which if you think logically, the middle of our data is at 18, so having an average of 17.7 is not necessarily so far off. They're both kind of close in this one. And we also want to find the outliers. Now, to first find the outliers, we have to find our interquartile range. So that's the IQR. And that's going to be the highest quartile minus the lower quartile. So that's 20 minus 14, which we get 6. And now I'm going to take 6 times 1.5. All right, and 6 times 1.5 is 9. So anything that's 9 below my Q1 or 9 above Q3 is going to be an outlier. All right, so it's kind of like I have this range. My box and the box and whisker plot goes from 14 to 20. That's my IQR. And so then anything that's more than 9, so anything above 29 or less than 9, so anything less than 5, is going to be outliers. Well, for this set of data, I only have one that works or qualifies there, and that's the 30. So I do have one outlier, and that's at 30. So the basics of a box and whisker plot, and I don't know what happened to my arrow here. That should be going up here. All right, you have your box. All right, remember that box is your IQR, your interquartile range. The lower quartile is the left side of your box, and the upper is the right side. And then your median is always going to be somewhere inside that box, not necessarily in the middle. All right, it can be anywhere over here. Then you have your minimum value and your maximum value. And remember, we're cutting our data into fourths, which means between each of these sections is the same number of data points. So each of these is going to be 25% of our data. Right? They're not all going to be the same length, but the same amount of data points are in between each of these markers. Now, whenever you have an outlier, you don't include that in your line, in your whisker, right? So if there was an outlier, we would have an extra little point out here for the outlier. And then our lowest point that's not an outlier starts our whisker. And same thing, you might have one or two up top that are outliers. Outliers are not connected, okay? So if I want to analyze this data, right here I have two classes with algebra scores. I want to know which class had the higher median. Well, here's a median and here's a median, so this means that class 1's median was around an 80 and class 2 was maybe a 75. So class 1 definitely had the higher median. All right, which class had the highest score? Well, class 1's highest was up here at a 90 and class 2 had 100. So class 2 had the higher score. For class 2, what percent of the students scored between a 70 and a 90? Where here's my 70 and here's my 90. So this is my interquartile range. And remember, each of these sections is 1/4. So this is two sections put together. So that means 50% scored between 70 and 90. And then in your opinion, which class did better? It is an opinion. It kind of depends. Class 2 had the highest of 100, but they also had the low of a 50. It looks like class 1 only had a low of 55, right? And then 50% of the class for class 2 was between 70 and 90, but 50% of class 1 was between maybe like 73 and maybe 85, 86, somewhere in that. So a majority of the class did, well or decent compared to kind of a broader range for class 2. So it all just kind of depends on, what you consider a class to be doing better. And that's your box and whisker plot.